Hello, I'm Tom Ferguson and welcome to The Fundamental Molecule. This show explores the intersection of water, technology, and entrepreneurship. Each week, I interview innovators, experts, entrepreneurs, and investors in the world of water, helping us understand where this trillion-dollar industry is headed. These are the stories of the people building the future of the world's most valuable and fundamental resource.
Disclaimer. Tom Ferguson is the managing partner of Virgin Island Ventures. All opinions expressed by Tom and podcast guests are solely their own opinions and do not reflect the opinions of Virgin Island Ventures. This podcast is for informational purposes only and should not be viewed as investment advice or relied upon as a basis for investment decisions.
Pierre Côté is arguably the most successful inventor and technologist in the industrial wastewater space. He has two ubiquitous technologies under his belt, the hollow fiber membrane and the membrane bioreactor, or MBR, and a third technology well on the way to becoming ubiquitous, the membrane aerated biofilm reactor, or MABR. Pierre is not only brilliant and a wonderful person, he is totally focused on finding practical solutions to persistent problems that are affordable and implementable. Pierre is now at it again with a new technology for dealing with nutrient pollution via an inexpensive algae biofilm process, being brought to life through AlgaFilm, our seventh investment in our second fund. He is a profoundly thoughtful, modest, and wise man, and his advice for technical founders is particularly on point. Please enjoy my conversation with the great Pierre Côté. Pierre, welcome. Really fantastic to have you here. How are you?
I'm very good, Tom. It's very nice to be on the fundamental molecule today, so I'm looking forward to our conversation.
Well, it's a big day for us. For people who aren't aware of your reputation, we've made sure in the introduction that they are aware of your reputation. It's really very exciting indeed. And I want to start with, I think, is kind of a core question, given your approach into the water sector, which is how your overall role is appraised within the product creation process. So what do you think that people most misunderstand about being an inventor? And then I've got a secondary question that comes up after that. But starting there, what do you think people most misunderstand about being an inventor, which is what you are, I think?
Well, maybe I could start by saying that ideas don't come in a vacuum. You need to be exposed to problems. So if you want to come up with inventions and innovation, you actually start by looking for problems. Very often, you also put yourself in an environment where there is pressure and stress, either self-generated or generated by your organization that have made some commitments for products or processes on which you're working. And all of that kind of end up being full engagement, problems, stress, pressure. In that environment, you want to see some risk taking, you want to see some mistakes made, and iterations. All of the inventions I've been involved with have come to fruition through a number of iterations. Very important to be surrounded with a team of people. Ideas don't come from brainstorming, they come from individuals, but the idea germ basically from interaction with other people. That's basically it. I could probably end by saying that if I want to pick a personality trait that characterizes an inventor, it's probably an introvert rather than an extrovert.
Why do you think being an introvert is so helpful, or why do you think that that's a determinant?
Well, because introverts live in their head and probably think about their problems more than extroverts who are busy interacting with other people. And I think maybe a secondary trait would be to be curious and willing to kind of look outside your field in terms of the kind of reading that you do. Because let's face it, very often what is considered an innovation in one field is something that has been achieved in another field.
I've always loved that idea, that an idea that belongs in one area, you transplant it to another and you said, look like a genius for taking something that is accepted to be common knowledge elsewhere. Can you just go a little bit deeper on that? I mean, how do you maintain the discipline? I know that natural curiosity is probably very helpful, But how do you know where to look? Do you know where to look? Do you just trust that there's a sort of a random walk of being aware of what's happening either scientifically or mechanically or in the engineering world in other spheres is enough to make sure that you have the contact with those ideas? How do you make sure that you have that contact?
It can happen at two levels. It can happen at the individual level by kind of forcing yourself to look around. You can read a lot of patents. If you read within a group of patents, inventions have been collected from different fields sometimes, and that will give you ideas. You can do this at the level of your team and the persons that you interact with. I think it's very important in a startup company or in an R&D group of a large company to have people with different backgrounds. Over the years, I've selected people that have good researcher qualities, but not necessarily in the silo where we're active. And that makes it easier to bring ideas or to bring solutions from other fields and adapt them to your own field.
When you talked about the information flows as fundamental to this, when people think about a technical team in a company, you always sort of, I think the easy way to think about it is people who are sort of, sequestered in the lab, building the thing that really matters to solve the individual problem, but not necessarily coming into contact with the customers who will be able to tell them about the nuances of what they know. How do you break that down? How do you make sure that you first, and then also all of your team, has that depth of knowledge about the customer and the nature of the problem that you're trying to solve, identify, whatever it would be? Is that something you think about?
It is when I started saying that you need to be exposed to problems to find solutions. I think you need to be out there with customers and at plants and understand the problems and the issues that they have. So that's part of the process.
I just wanted to make sure that I'd heard one thing correctly, is that you mentioned commitment, and it sounded like it was maybe the commitments of sales teams in terms of the provision of value propositions to your customers that weren't necessarily captured by the product as yet. Is that fair? What's your experience of working with people who will, not to throw salespeople under the bus, but if they will promise the moon to the customers, and then it's the job of the technical team and the people who are actually building the product to deliver that value proposition? I think you mentioned a mismatch, but I may have misheard you.
I may not have mentioned it, but it's a good point. I don't have a problem with that, and I've been in that situation often.
Well, it's very kind of you. I'd imagine it's annoying.
No, but I mean, setting the bar high is a good way to, getting across the line with something that's worth it. It's not a problem. You take it with a grain of salt.
Yes, exactly. Your latest company, which we are absolutely delighted to be investors in, is AlgaFilm. I think a really good way of illustrating your process, maybe just talking about where the idea came from in the first place.
Somehow you're responsible for it, because I think you're the one who, about 4 or 5 years ago, introduced me to the CEO of an algae company, which was a startup at the time. And I had that conversation, and at the time I was doing consulting, and the guy was looking for somebody to help take cost out of their product. So I listened to him, and within about half an hour, I looked at him and I said, I don't think that you need to take cost out of this product. You need a better product, a simpler product. I didn't get the job as a consultant, but this started me thinking about the problem, and it became some kind of an obsession. Algae can do interesting things, but if we look at the processes that are in existence and are commercialized, you either have ponds where algae grow in suspension, and these are too large on the one hand. On the other hand, you've had companies that have built very efficient system, but they're complex and expensive. So that was kind of my starting point. I knew nothing about algae. So I read a bunch of articles, I read a bunch of patents, and I started calling people that I knew that would know something about algae. I found myself at some point with an idea that I wanted to validate, and I put together couple of little systems in my garage. It was the summer, so it was the right place to do it.
Handy, especially in Canada. Yeah.
Yeah, but by October, I was only halfway through the experiment, so I moved the reactors down in the basement and I carried out there.
That's great.
That idea, as in many cases, turned out to be not so good, and I abandoned it after a year. But that led to the solution that we've adopted at AlgaFilm, and we're in the process of commercializing now. So I don't think we need to talk about the details, but we're growing the algae in a biofilm on stationary carriers. It's really simple. It's low-cost materials, but it's as efficient as the complex systems that you see out there.
So just to make it sort of clear, like visually, for people who may be listening to this and want to know what it looks like, describe the array and where it kind of fits within the treatment plant process. Exactly what is going on. Well, describe it first, and then we'll get into the things that we think is really compelling because it shows your degree of understanding of the customer and the nature of their kind of existence and what they need to be true for this product to be effective.
Yeah, we call it algae forest. And you can basically picture it as a large number of Christmas trees sitting side by side. They're green because algae grow on the surface. They're cones made out of an engineered fabric. And the algae, because they're cones, they're open to light from all angles. They're very efficient in growing algae on a per square foot or square meter basis. You basically irrigate them with the wastewater on a schedule, roughly weekly. You go through a harvest exercise to remove the excess algae. And then you restart the cycle. Really simple, no chemicals, very little energy required because it's powered by the sun. You just need a little bit of pumping energy. And very good at removing nutrients from water, and knowing that the process of photosynthesis produces oxygen, a lot of oxygen. In a wastewater environment, you end up with a biofilm that is mixotropic, contains both algae and bacteria. We know that algae do not remove organic carbon, but the bacteria will do that. So they work together in that sense.
And then from the point of view of the treatment plant operator, exactly how would you describe the value proposition to them? Why are they going to be buying your system? What is the value? Like, what problem are you solving for them particularly?
We're making it a lot easier to remove nutrients because with conventional activated sludge or bacteria-based processes, you either need to put in a lot of energy through fine bubble aeration or to add chemicals to precipitate phosphorus or a source of organic carbon to have deeper denitrification. So we can do basically the same thing without chemicals and at a very low energy. Now, algae have a lot of good fundamental qualities, as we've said, but they also have some weaknesses. They only work well when the sun is out. We tend to look at putting our system within an existing treatment where we don't have to be the last process before discharge and having to beat sometimes stringent effluent criteria. We tend to bring ourselves upstream and do the hard work and let a conventional system polish the effluent before discharge. We're finding good traction and good applications in upgrading lagoons. And obviously, as we move south and there is more sun and warmer temperature, then we can become the main treatment process.
So Algae Tech, I spent a little bit of time while at business were looking at an array of different businesses, and they've historically been quite tricky. What do you think has been misunderstood? I'd be very curious as to, you mentioned a little bit of your design principles in terms of, simplicity and the rest of it. But why do you think it's been difficult, and what have people misunderstood that you think that you're doing correctly this time?
I think a lot of the bad reputation of algae come from the fact that they were very, very popular about 15, 20 years ago as a way to make a biofuel, as a feedstock for a biofuel. There was a real bubble that was created, hundreds of millions spent promoting ideas and approaches that were not necessarily well adapted.
Yes. Commercial, good.
Yeah.
Sure.
Many of the companies that were involved there failed, and others kind of a few of them transitioned to wastewater treatment. But I would say up until a few years ago, maybe 5-6 years ago, there had been very little effort developing a real good algae-based system focused on wastewater treatment. It had been focused on something else where money was not the issue because of the environment at the time. If you start looking at algae with an objective of applying it for wastewater treatment, one, and two, if you are from the field and you understand what is acceptable and what is the price point that would be attractive in wastewater treatment, you end up with a different product.
And you can also discard the structures or the mode of the delivery of the value proposition that just don't work underneath those structures, which is incredibly helpful.
So it's not more complicated than that. I think it's focusing on wastewater and kind of knowing the field and what's acceptable in the field.
Exactly. That idea of acceptability. I'm just really curious as to how you see this sort of like fitting in, whether there were similarities and differences between two previous, really game-changing for global water invention stuff, hollow fiber membrane and the membrane-aerated bioreactor. As you look back on these three things, is there anything particular that stands out to you in terms of commonality of the process of bringing it together? Is there anything particularly different that you think you're doing now? I just think that a historical context is fascinating.
There are a few things that are the same and a few things that are quite different. What's the same is that there's always mistakes and iterations. I kind of look back at the other products that I worked on, and the first one, which was the MABR immersed membrane, there were 2 iterations. The first one was significant. I think we spent about $3 million going in the wrong direction until we had to stop that and restart with the idea of the submerged membrane. The second one was the same thing. That was a submerged membrane for drinking water production. Again, 2 iterations. The first one was trying to do something really fancy, make fine hollow fiber membranes in the form of a carpet, really tiny fibers. That failed, and we restarted. The third one would be a membrane aerated biofilm reactor. And that one, we actually had 4 iterations until we came up with the product that was commercialized. In some cases, we killed a product and didn't restart it 2 or 3 years later, with different management and different focus in mind. So anyway, mistakes in iteration is what has been the same. So what's different back then as compared to now is that back then I've always worked with established companies, not necessarily super large companies, but established companies where there was business leadership in place and good teams in place. While right now, I find that the startup VC-funded environment is quite different.
Interesting. How so?
There's limited funding, limited runway. I could say now we would need to hire about 6 people with different skill set to keep going, but we're not ready to do that, and we don't have the budget to do that. The constraints are there, and in a way, it may be a good thing because it forces us to focus on the pain points and the things that would allow us to move it to the next stage. Maybe it was the same with my old company, Xenon Environmental, because the situation was the same, but those worries were the worries of my boss, not myself.
Do you like that? Do you prefer the old model where that is absent?
As an individual, absolutely.
Maybe that's an unsurprising answer.
Yeah.
It's a different type of pressure. What I was going to ask you was that do you prefer the idea of innovating and moving through the product iterations with that kind of air cover? Or do you like being out, knowing that this is a small team doing something sequentially, moving through the various proof points that need to be in place to be able to bring on that, extra budget to move it through into the next stages? Which model of creation do you prefer?
Whether it's a large organization or a small organization, I like to focus on the technical work and problem solving. And I like to have somebody with me that takes care of the environment and interacts with the outside world. Just my nature, I guess.
To make sure that you have that conduit. That's really interesting. The other thing you mentioned that I wanted to ask you about is, what does failure feel like? And I mean failure as opposed to not yet. That we're on a pathway where this iteration hasn't worked, but we just need to do the next iteration and the next iteration, and then we're going to get to something that will work, rather than actually we're barking up the wrong tree and we need to go and do something else. Like, how do you know? Is that kind of a synthetic thing? Is that something you feel in your bones? Like, how do you know the difference? Because we see an awful lot of entrepreneurs who probably should have decided to go and do something else. There is a difference between unwise dogmatism and wise dogmatism, if you see what I mean.
I don't have a problem with failure. In the worst case, you're cutting your losses early, recognizing that. I've always been the most critical, or have the most critical look at what we were doing, and ready to say, this is not working. We need to find a way around this, or we need to stop. And I've had many of those conversations with my colleagues.
I can only imagine. Okay, so it's kind of a collective thing. And then the other one was that I wanted to ask you was thinking about the commercialization of your inventions. I think you're a really special case because you've already said you already think like a commercial founder, that you're focused on the problems that are out there and then the reality of the customer that's there, rather than the kind of inherent beauty of the technical invention that you're bringing to life. I just want to give you some space to talk about the necessity of commercialization and how that interacts with your work in the lab. What is the relationship between the lab and the marketplace?
I think on maybe 2 or 3 different levels, I think as researchers or developers, we need to be committed to make a product that works and be able to go and fix our mistakes if we've been in the field early, which is desirable, and failed. In our field, as probably in all other fields, but more in water, I think you need to find early adopters, people that get excited about new technology and ideas. And these people are precious. You need to treat them well, and you need to make sure that they come out winners as well in the whole process. And maybe the third point I could make is that very often new products or processes that we are working on only solve a small portion of a problem that a customer has. As a startup company, I think it's important to try to integrate your portion of the solution with other elements that make it a total solution for the end user, and not go out and try to sell your gimmick that is not a total solution to their problems. So we're in a better position through alliances, or to come out and say, okay, we have this new trick here, but it's not going to solve your problem unless we do this and that at the same time.
We talk about the idea of the whole solution without, it's one of the things, well, it's a weird thing that we don't have to talk about that much because we select our founders on the basis of really having a deep understanding of the whole solution. But this idea of the whole solution is so key that in IKEA, for example, without that 1 cent or half-cent piece of paper that has the instructions printed on it, what is in that box is essentially useless. It's great to have this like awesome piece of Swedish design, but unless you have the instruction manual, you have no idea what you're doing, and you're never going to derive the value proposition from it. Such an interesting and cool idea. When you think about either the technical founders or the people that you've worked with that have gone after other companies, or reflecting on your own experience, what do you think that the more technically minded founders or members of founding teams get wrong? So if they struggle, why does that usually happen? And sort of with a view to how they can avoid it. Not so many people have the depth of experience here that you do.
I think very often people express their objectives in terms of a mean rather than a goal. So if you express your objective as a goal, solving this problem, as opposed to making this little piece of equipment a commercial product. So if your objective is the goal, the little piece of equipment becomes disposable. It's easier to stop and reset or change direction if you don't need to change the goal. I see a lot of founders that express their objectives in terms of means rather than goals, as a first point.
That usually manifests in our experience. It manifests a lot with people who are looking to commercialize things like their PhD projects. They're rewarded by the system that they are in terms of making an improvement on the kind of best available science. And then, they get their PhD and then they want to take it out into the world. And they find often that people care a lot less about it than they do. How would you get around it? What advice would you give to technically minded founders who are coming out of, for example, PhD programs, or they could have been, building something in their basement or whatever, to make sure that they fall in love with the goal and not the invention?
Right off the bat, I think they need to broaden their scope and understand their competition, what they're proposing, how is it done currently in the marketplace. There's very few, very fundamental innovations in water. I know it's very incremental, and you always have competitive products or approaches to compare yourself with. In everything that I've done or with our team, we've forced ourselves to study competitive products and develop early costing models or solution versus other solutions. Initially, it's really plus or minus 50%, but at least it gives you a framework to look at it and fill in pieces as you learn more. And I have a decision tool, basically, that allows you to focus on your efforts in R&D on the right things, because you can see that in a model or in a cost model.
So it's the imposition of that structure, especially early, to make sure that you're adhering to what's going to matter in the end, which is you can build the thing, but if you can't build the thing according to a cost structure that is going to mean that it's going to have sustainability in the marketplace, then what are we all doing here?
I'm going to make another point, which I don't know how valid it is, but
I'm sure it'll be very valid, Pierre.
Yeah, no, but it has some relationship to the work that you do. But I see people that are very good salesmen and end up raising too much money and waste it. I've seen so many VCs that want to be told a good story. And I think in the experience that I've had with you, you have done a very good due diligence job. But I've also seen situations with a lot of money flow with very little fundamental understanding of what the startups are doing. It's not a problem in itself, but the problem is that I think, and we maybe started with that, it's important to have your team in a little bit of a stressful, motivating, positive situation. And if people don't feel that, okay, we have a limited runway or we have limited resources, I find that it doesn't help with focus.
No, absolutely. It really doesn't. And I was sort of think that there's nothing more pernicious than an absolutely exceptional storyteller with an idea that's wrong.
Yeah, exactly.
Yeah.
That's what I was trying to say.
It's really tough because it's often very difficult to know the difference. This is one of the advantages, definitely, about being a specialist. The other thing that makes me reflect on is that I don't know how many within Fund 2, where a good proportion, I think it may be as high as 50%, are companies that we have been tracking for multiple years. And that actually we know that they've been through the wilderness a little bit of having relatively thin resources, and that they've got this far on those thin resources. And my God, is it a good leading indicator for the type of behavior that they've had to learn that is going to stand them in very good stead. Of course, it's been terribly frustrating, I'm sure, at lots of different junctures of the company building process, but they learn habits in a way that people who have just sort of had 25 million or $400 million just dropped on their heads, and they get to a vaporization rate that is just really, really, really unhelpful.
Yeah, exactly.
It's great to hear it from your side of it. Pierre, for the last section of this, I want to change gears a little bit because you've got a perspective on our sector that few people do. But I want to start with, you could have done a lot of things. Why did you end up in water? You were incredibly grateful that you did. I don't want to sound, but what led you here in the first place? Why did you become a water person? Why didn't you apply your talents elsewhere?
Very simple. It goes back to teenage ideal, where I wanted to do something good for the world, environment, water, without any preconceived very precise idea of where that was going to lead me. But that was the motivation.
That's so interesting. And I think it's a real theme that we've heard a lot in this chat, which is the avoidance of preconceptions. Is that like, okay, I'm just going to do this thing, and how I do it, I'm open to, but we know sort of what the hill kind of looks like. and let's go after it. And has anything kept you in it? I love this idea that once sort of water sinks its teeth into you, it doesn't tend to let go. And so many talented people stick around because they can't end up not imagining doing anything else. How has that kind of manifested for you?
I think I was lucky enough to have it as a thesis supervisor and first boss, Andrew Benedek, who been a real pioneer in the field and, has been a good mentor to me and allowed me to do very interesting things early. For example, becoming the R&D director of a membrane group while I had zero experience in membranes.
Wow, it's fine. Outsider's perspective.
Right, exactly. Yeah.
That's great. Now, Andrew is, true gent. He's been extraordinarily helpful to me over the years as well. And then on the water sector itself, what are the big things that you think haven't changed but should have done?
I'm not sure. I think that over my career, the things that haven't changed is the fact that the market is very fragmented and it's very difficult to come up with universal approaches and products that fit all. Even if they do, delivery method from a commercial point of view is completely different. So it's a real tough thing to work in water from that point of view, and that hasn't changed. But other than that, there's a lot of things that have changed over the duration of my career. And when I started working on membranes in water, it was a dream. Will membranes ever be used broadly to treat water? They had characteristics that made them very attractive for that. And I've seen that happen, and I'm very grateful to have been part of it. Water reuse, we still have ways to go, but it's now very well established. A lot of intensification of processes have taken place, a lot of that with biofilm reactors and membranes. I've seen RO replace thermal processes for desalination. So a lot has happened over the past 30, 40 years.
I mean, obviously, AlgaFilm becoming totally standard in the removal of organics. That's going to be one of the major themes over the next decade. What do you think the next decade is going to look like? And what do you think that I don't know whether there's going to be a good answer to this, but what would you like to see invented that we haven't yet? Or what would you like to see the scientists and then inventors of the future working on in the next 10 years?
That's a tough one. In terms of the next decade, I think that one way to look at it is to look at mega trends. I can identify three that I think are significant. And one of them is population stabilization and decline. The second one would be climate change. And the third one would be AI, artificial intelligence. If we start with population decline, I think it's happening at the scale of the world. But locally, I think because there's also going to be more migration, mostly from areas of the world where water is not treated to areas of the world where water is treated, I think that's going to fuel growth. So growth will not necessarily come from population increase, but from migration and from climate change as well, in terms of its impact on making some areas more arid and some other areas wetter. I think we might see in the next decade more emphasis on infrastructure and less on treatment itself. When you see the need for flood control, dams, rebuilding storm sewers, combined sewers. I mean, we used to design things for a rain of 1 in 100 years, and now we get that every 2 years.
Yeah, every 2, exactly.
So maybe it's not as sexy as fancy treatment process to remove PFAS, but
obviously,
building the infrastructure or improving the infrastructure can save lots of lives as well. In terms of also what I see as a bit of a trend is I think we're going to be using our existing assets, much better through analysis and monitoring, data mining, and use of artificial intelligence in running our system. So without spending a lot of money investments or in more infrastructure, we can use what we have better with those emerging tools. As far as what's the next great process that has not been invented, I'd love to tell you, but I don't know what it is.
It's all right. We know what it is. It's the AlgaFilm forest.
Yeah, there you go.
Yeah, we already know. We already know because you're already there. It would be so fantastic to hit the fully kind of transformational hat trick within the water sector. Pierre, this has been as much of a pleasure as I knew it would be. We have come to the time for our traditional closing question for our guests, which is that if you had to choose one piece of advice for current and future water entrepreneurs, what would that piece of advice be?
It's tough to limit it to one, but I'll start with one and I'll complement with a few other things. I think focus on building a strong team of people with fundamental tools, but with expertise in some cases outside of the focus of your company. So strong team, but not necessarily experts in your silo. And the second part of this one thing, look for a wave, carry you to the market. We've seen a lot of waves, and they're not under our control very often. There are regulations. We can think of parasites and crypto and giardia 30 years ago, water reuse. Today, it's PFAS, but there's got to be some excitement, some wave that you can carry. And very often, it's just luck. So you need to be lucky as well.
Yeah, absolutely.
It's not sufficient to be good.
Yeah, absolutely. Absolutely. I think about it a lot as be lucky and good. But yeah, that's really fantastic. The point about the team is absolutely crucial. I love this idea of making sure that you're building in something structurally that allows you to leverage and benefit from things that have already been figured out in other adjacencies. It's really valuable. Thank you so much for being here. Really appreciate you being a guest on The Fundamental Molecule, and we'll speak to you soon.
Thanks for hosting me. Bye-bye.
Wonderful. Bye-bye.